So let's begin by talking about how we can prove triangles are similar. In order to prove that we have sides that are, in order to prove that the triangles are similar, we have to use one of those three theorems. So if we're using sides, then we have to prove that the sides are proportional. So similar sides prove with proportion. So two ratios, setting them equal. For angles, we want to prove using common angles or a reflexive. All except either one of those as your reasoning. Vertical angles, alternate interior or corresponding. Those two, alternate interior and corresponding, must have parallel lines in order to prove that. So once you have enough similar sides, proportional sides, or congruent angles, use one of the three similarity theorems to prove the triangles similar, such as angle-angle similarity, side-angle-side similarity, or side-side-side similarity. All right, we're going to prove the triangles are similar. Okay, so write down your given. It says that AED, so I'm going to go over to my image here. AED, sorry, these letters are real small. AED is here. That angle is congruent to ACB here. I am trying to prove that triangle ACB, the large triangle, is congruent to AED, this small triangle. Pegs?
So, angle A is congruent to angle A.
Very good. We got the next step. Good. So angle A is a part of both of those triangles. So our next step is going to be to say that angle A is congruent to angle A. And reasoning will be common angles. Or you could say reflexive. And you know, sometimes when you're given boxes, you have extras. That's okay. I have two angles congruent for each triangle. Good. I have enough information now to say angle-angle similarity. In my proof, I do not need to write that the third angle is congruent to the other third angle. I could if I wanted to. So if I wanted to say that angle B is congruent to this angle D here, my reasoning would be sum of the interior angles equals 180. I do not need to write that though. So my third step can be to go ahead and write my proof step right in here. So triangle ACB is similar to triangle AED. And Evan had it right, angle-angle similarity. Questions on one? Okay, number two. We've already written our given down. It says ED here is parallel to CB. Okay, the only reason that we're probably using parallel is to try to get alternate interior or corresponding angles. Evan? Good, jumping right in with that reflexive angle. So step 2 is going to say angle A is congruent to angle A. Common angle or reflexive. I'm going to write both for our notes, but you can write either one. Whatever you want. You don't have to write both. Yeah. Oh, next step? Okay, Grace? Okay, great. Corresponding angles. Which angles do you have?
I chose
B and D. Okay, so I'm going to use 3 letters just because angle D here, it could be this top half or this bottom half. So we'll have to use 3 letters for both. So we'll say angle A, D, E is congruent to angle ABC. And Grace said corresponding angles. Absolutely. So this question was nice because we could have said both of the corresponding, because this angle E and this angle C are also corresponding, which means that this could have been a 3-step proof instead of 4 if you wanted to.
So it could have been angle.
This one is going to be angle, angle. So still angle, angle, because I just have 2 angles here. And I'm going to say triangle AED is similar to triangle ACB. So what I was kind of saying is, if I didn't talk about this reflexive angle, step 2 would be kind of deleted. Step 3, I could include these 2 angles and these 2 angles in that same step because it's the same reason. Don't have to, though. When you're given a proof that does not have any numbers or measurements on here, you want to try to tackle angle-angle similarity, because you can't set up any proportions with numbers that you don't have. So you're not even really thinking about side, 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 or side, angle, side if we don't have any measurements. Questions? Okay, let's step it up a notch. Go to the next side. You've already written that given. So let's go ahead and read through that given together. It says AB is parallel to BE. So AB is here, BE is here. And I said parallel, but I meant perpendicular. So we're going to create a right angle here. And then DE here is perpendicular to BE, so we have another right angle. Before I go any further, I'm probably going to be trying to use side angle side. So in my proof somewhere, I want to say that these 2 angles are equal to each other, or congruent to each other. So let's keep that on the back of our minds. Keep labeling. AB here is 12. BC, so from here all the way to here, will be 32. DE will be 9. And FE from here to here will be 24. Okay, good. So I noticed that I'm not given the third side, so I am trying to tackle side, angle, side. So let's go ahead and talk about the angle before we jump into those sides. So I want to be able to say that they are congruent. So I'm going to list these 2 angles. So I can use 3 letters if I want to, or I can just say angle B is congruent to angle E. And I'm going to use, the reason is we have perpendicular for both of those. So definition of perpendicular. This next step is going to be to start talking about the sides. So I need to set up a ratio from both triangles, and then I'm going to simplify. And I'm actually going to do it all in one step over here, so it is a little bit different than the last proofs that we've done. So let's set up a ratio from my triangle on the left to my triangle on the right. This long. Yep. Oh, she just got here. Okay. So let's go from the shorter side, AB. I'm going to use letters first. AB over, the shorter side over here is DE. And this is just a ratio. So definition of a ratio is what we're going to be using as a reasoning. So now let's plug in the numbers. So that'll be 12 over 9. And we want to be able to compare our ratios. So let's reduce this to get our scale factor. So if I divide both of them by 3, 12 divided by 3 is 4. 9 divided by 3 is 3. Let's set up a ratio for the other side. So using letters, that would be BC over EF. BC is 32 over 24. Oh, do these marks?
Yeah.
Yes, you can just write those little marks, or you can write it out again, definition of a ratio. Oops, ratio. Either one is fine.
If you also do it in the same step.
Yes, so because the question is, could I make these in the same step? Yes, since they're the same reason, I could pull this up over here. It just might be a lot going on one line. Let's go ahead and simplify this fraction. 32 and 24 are both divisible by what number? 8. Okay, so 32 divided by 8 is 4. 24 divided by 8 is 3. All right, so both of these ratios equal 4/3. So I can kind of ignore this middle. If both of these ratios equal 4/3, then I can say that both of these sides equal each other, and that is saying that the ratios are proportional, which is what I wanted to prove. So what property allows me to say if this equals 4/3 and this equals 4/3, then these equal each other? Transitive, just like we talked about before. So step 5 is going to say transitive. So AB over DE equals BC over EF. What we've just written are the ratios are proportional. Now that we have proportional sides and one angle congruent that is sandwiched between those sides, Evan? Side angle, side similarity. Very good. So triangle, I'm going to make it look exactly like my proof step up here. So triangle ABC is similar to triangle DEF. Questions? Again, that was a more challenging one. Okay, number 4, we are going to walk through together. I did give you the left side of the proof. So step 1 is always your given. And I did list the entire given in that step. So ABDF is a parallelogram. Then I said that BF is parallel. BF is parallel to CE. So I need the parallels in order to say like alternate interior or corresponding. You need to say that they're parallel first. I'm trying to prove that triangle FAB there is similar to CED, this one. I don't have any sides, So I'm thinking angle-angle similarity. Just how do I get there? Okay, so the first thing that I have over here, step 2, is to say that AB is parallel to FD. How do we know that that's true? Scott? Good. So it is the definition of parallelogram. I'm just going to dive a little bit deeper and say the opposite sides of a parallelogram are parallel. Because our parallelograms have so many definitions that define them, I'm just going to choose the very specific one we used. Okay, so why would I want to say that? Probably because I'm going to try to use something about opposite angles being congruent or something about alternate interior angles. So let's see which one I went with. So I said that ABF, this angle, is congruent to DFB, this angle. What makes that true? Alternate interior angles. Okay. Next step says DFB, we just marked that one, is congruent to DEC. This one has 1 mark, so I'm going to give this 1 mark as well. How is that true? Corresponding angles. Good. With these parallel lines, those would be corresponding. So now visually, if I look at my 2 orange triangles, I can see inside both of them, I now have B and E here marked with 1 mark. Now we can't really write that in our proof, but we can use that knowledge to drive our proof. So my next step, I did say that ABF, this one, is congruent to DEC. Now why is that true? Anyone have an idea? It will be transitive. So ABF is congruent to DFB and DEC is congruent to DFB. So now I can take the opposite sides and set them congruent to each other. So that will be transitive. All right, so we successfully tackled 1 angle. We only need 2, so we're almost there. So I'm thinking, is there any way for me to talk about angle C? I don't see one right away, but I have in my proof, I already gave you it, A and D are congruent. So how is angle D and A congruent? Good. So we're using those parallelogram properties. So opposite angles of a parallelogram are congruent. Now that I have 2 sets of angles congruent, I know the third would be through interior angle sum. So I now have enough information to say the triangles are similar through which theorem? AA. So angle, angle similarity. Oops. Questions?